Hey, good morning.
We've got
I hope
Fentent.
you heard me. Did you?
Yes, I did hear
I can
you.
hear you.
Okay, great. Thanks.
Good morning. I'm
Okay.
sorry.
So Shiva, I see that you're online. Could you please confirm that your audio is working? And just for your information, so our two speakers from Juniper, their full Indian names are not the names that they'll go by. So if you look at scroll down, you'll see Vakata Avula, that is Shiva,
Yep, that
and
is Shiva.
Jayanth is bouncing on and offline. That's Minto, and they're the speakers for the Juniper slides.
Okay.
I'll message Shiva directly.
We're only missing Robert is back? Not.
Yeah, Robert just rejoined. Robert, could you please test your audio?
Fentet, would you like to test? Oh, Shiva, would you like to test your audio, please?
Uh, yes, so hey, are you able to hear me? Good morning, sir.
Yes, I am able to hear you. Thank you for testing your audio.
Mhm.
Robert, could you at least say hi? How you doing this morning? We need to make sure your audio works.
Robert just bounced offline.
Okay. Well,
We're
since
having our
we're having our moments of joy for this morning. Okay.
Robert just
Okay.
rejoined.
Robert, could you say hi this morning? Just try to get in the mic queue and say hi.
Robert is saying in his private chat that his audio is denied.
Okay.
I suggested that he swap browsers.
I think so. I don't see anything where I'm denying him. Ajun, would you like to say hi this morning before we start so you're ready? Asian? 'Hi,
Also
folks. We're
sending in
going
our
to
private
start in
chat.
just a minute. Oh,
And while we're
okay.
trying to get the rest of our speakers going, if you also want to test your microphone, make sure that things are working fine, now is a good time.
I'm
Aishan, we can
not.
see you at the microphone.
Hello.
We don't hear you though.
Yeah. So Jeff, you can hear me?
Yes, I can
You are
hear you
very
now.
faint.
Yeah.
Could you increase
You
your
sa-
mic?
if you are using a headset, it sounds like it's coming from your open microphone rather than headset.
So I will mute the audio.
Thank you, Aishan.
Jeff, I believe the introduction is yours, so I think we've got
Okay.
Asian. The only one we're waiting for is Robert.
Okay, Robert was
Unfortunately,
the first presentation, so we may reorder if that's the case.
yep.
And Shiva confirms that he is the presenter of the two. Okay.
Okay, so we
So-
can start with that. Go ahead.
Okay, so good morning, everyone. Good afternoon, good evening, wherever you are on the planet. So this is the IDR interim for BGP auto configuration. And the scope of this session is two things. First is working through auto configuration as a discussion topic, specifically towards the proposed protocol extensions to implement the design team document. We also will have a presentation at the end of the session covering the VPN ORF functionality that Ajun's been talking about on IDR. So for the auto configuration design stuff, we'll be reviewing the scope of the problem and the auto configuration protocol requirements. Next slide, please. So this is from our design team document that cleared working group adoption. And the target environment is for auto configuration is BGP as used for underlay routing protocols in data center networks. So one of the discussion points we will come back to as we work through the proposals is, how does this actually serve that environment? However, other scenarios may be considered as part of our analysis, but work on those environments may be deferred to other efforts. So part of the discussion points as you're working through your presentation, please focus on how do you actually address either the target environment or potentially future environments. Next slide, please. So this is a reminder from the AutoConf considerations document. The required state that we decided as part of the discussion through the design team and the working group list was that the auto configuration protocol is primarily there to let an implementation know what the BGP session transport state is going to be, and the state that we're going to be learning that's necessary for the protocol to be able to function for discovering BGP session endpoints is obviously the this is for BGP. We did discuss that the easiest way to avoid repeated connections to a BGP session that is not going to change its properties and on a regular basis is to exchange a BGP session protocol state version number. This is just a hint that the configuration may have changed, and if you got told no, you can't connect on round 1, maybe round 2 will work. And clearly the rest of the stuff is mostly towards getting a BGP session to come up at the TCP layer. So this includes the IP addresses, at whatever address families we're trying to work through. Transport security parameters. So as an examples of that, are you using a keychain, are you using MD5, using AO? Is there a keychain ID that you should be agreeing upon? Those things are necessary to get your session, your TCP to even come up. And very similarly, if you're using GTSM, you need to know and agree on that ahead of time. Otherwise, your TCP may not even connect. One of the discussion points in the document is that BFD strict mode should be implemented. This avoids implementations from bringing up BGP sessions halfway and having them die if BFD is not appropriately provisioned. The rest of the state the design team discussed was to be discovered from BGP itself. So once BGP transport sessions connected and we start the BGP state machine, the BGP open is going to supply the rest of the information for a client that is looking to use auto configuration to decide if this session is acceptable or not. This information included the AS numbers, the BGP identifier, supported AFI-SAFIs. We did discuss, and this should have been deleted, I apologize. Device role was a basically optional information that may be exchanged, either capabilities or some future information to decide if you want the session to connect or not. And the discussion point basically is that this information should not be duplicated in the auto configuration protocol itself to avoid mismatch of information and potentially confusing operations. Next slide, please. So the discussion points we'd like to ask each of the presenters to work through as you're giving your presentation. So these are some of the points, and some of these things have been discussed in prior interims. What network layer is your auto configuration protocol running on? So is it running L2, L3, L3 unicast, L3 multicast? At a higher layer, as an example, Robert's presentation looks like it's targeted effectively towards layer 7, where BGP itself is the distribution protocol. What's the state model for your protocol? Does it require some sort of session? So example would be like Xiaohu's draft, which is not being presented today, did actually require bringing up a two-way session for the mechanism to work. Some of these mechanisms are basically without session. Some of them are basically shouted in the dark, and you get to hear what the state is. So in those circumstances, it's effectively sessionless, and the information is cached. And the caching discipline is one of the discussion points. And certainly, once you've actually discovered the information from the protocol, what are the trigger points with the BGP finite state machine, and how does this actually interact with things? So this impacts things like how often do you retry? What is the expected retrying disciplines for things for the connect retry timers? Those sorts of matters. Next slide. Actually, this may be last slide.
Jeff, did you intend to have something else?
Nope, this may have been the last slide. Sorry, I forgot if I had to slide past this one. So again, these are the points we're hoping to have touched upon as part of your presentations. So the next piece is for us to move on to our presenters. I believe Robert is first in the queue that from our agenda. Robert, you said you think you fixed your mic. Could you test, please?
Hello, can you hear me?
I can hear you, Robert.
Wonderful, Robert.
Okay, good. It was Chrom's fault. Yeah, the Meet Echo was pretty much locked to be disabled by microphone. Okay, so today the topic of auto discovery came back, and I thought I'd bring back the one of the ideas which we have been working on for many years. Actually started in 2004, and it's not actually focused on data center. It is focused on WAN, and later we have added the IXP to the mix as well. So a bit of history. As I mentioned, it started 2004. Original version, which I presented in Vienna, IETF, was actually decoupled the flooding in IGPs to build the BGP sessions between BGP speakers, interested BGP speakers. It was called Auto Mesh originally. So after this, the feedback was to actually, and it was actually in one big draft. So after this, the feedback from the IDR and also OSPF and ISIS working groups at that time was, let's decouple this to 3 different documents and try to put it through the process. So I did split this to OSPF and ISIS drafts, and then left the BGP part in IDR. However, after discussing this more with some of the colleagues, we concluded that it may be much leaner idea to contain it together in BGP instead of using IGPs for flooding, because use of IGPs has pros and cons, and if you are just talking about setting up BGP sessions, maybe it's good to keep it together. And the first year of the draft, which used the BGP all-inclusive method, was proposed in 2005 with Pedro, Rex, and Chandra, and Kaur as well. So that was the history behind it. So in overview, basically the idea is pretty simple. Why do we need to continue establishing BGP sessions by hand? And
Robert, if I could interrupt you for a second.
yeah,
Thank you. The slides were not following you, so are we currently at the correct slide for your discussion?
yes, currently in the 5th slide, right? Yeah, exactly.
Thank you.
Oh, because I was swapping my local version. Okay, sorry. So basically, the question was, why do we need to keep establishing IBGP sessions by hand if we want to do the BGP full mesh? Of course, it was not targeted originally for eBGP sessions in general, for any eBGP session, because for establishing tier 1, tier 2, or even tier 3's BGP sessions, eBGP sessions, the BGP session is the least worry. The biggest headache and biggest work is in the policy configuration. So we never thought that automating of just bringing up BGP across different parties is a good idea, especially of different parties with different policies. But then we spoke with John Mitchell and Warren, and they have the idea called, Warren's draft called IDR sociality, or however, socialite. And that was kind of extension of route server to establish in the case of the open peering directly BGP sessions, eBGP sessions between IXP participants. So we thought there is so much overlap between both ideas using establishing IBGP in WANs or MANs and establishing peering with the IXP environments, and that time actually IXPs started to seriously grow for the right reasons, as we know. So we thought about, let's combine the work together and join the drafts. So from which was the year, from 2014, pretty much the drafts were joined. Next slide, please. So we are not really proposing to remove route reflectors. So this is not to be replacing route reflectors. It is just another tool in the toolbox to allow operators to simplify provisioning of BGP peerings. And it could be so that some of them may actually use automatic peering for some SAFIs and still route reflection for the others. So there's various use cases for BGP today, as we all know, and there may be needs to have the full mesh for some SAFIs, as opposed to always go to the route reflector. Next one. Couple of points. Why do we need RR? So what are the main use cases for RRs? I mean, this is, I think I have already presented some of this, so if this is boring, I apologize, but I just wanted to refresh everyone's understanding of this work. So pretty much there are 4 reasons for route reflectors. One is of course, configuration simplification. The other one is information reduction. And then a third one is optimization of number of TCP sessions to be handled by each BGP speaker. And the fourth one is pretty much along the lines of implementation details of generating updates and basically how we build the update message and how do we replicate the update message to BGP peers. So this proposal addresses number 1. And now let's discuss number 2 through 4. So next slide. Information reduction, yes. So let's observe that in number of address families, there is no information reduction already on the route reflectors, because if you use different RD per verb, let's say in L3 VPN or L2 VPN, then you're pretty much propagating all the paths everywhere. And maybe this is good, and this is actually good, not maybe. So this is good design, and there is no reduction. There is some reduction, for example, when you are IP ISP and have, let's say, 100 of different eBGP external peering points, and you may be getting even full table from all of them. So in this case, indeed, you may end up into getting 100 paths if you do the full mesh, which is not desired. So in those cases, you are much better off to get at least 2 paths, maybe 3 paths, using either add paths or diverse path methods. But in many other networks, getting even a couple of paths is no harm and simplifies operations, as well as provides ready paths for fast connectivity restoration. Next one, please. Reduction of number of TCP sessions still comes up sometimes, but I always bring the example of a little web server where it can handle thousands of TCP sessions concurrently. So today, the same with our routers on the RPs or REs, a number of TCP sessions which can be built, it's not really a problem. It's more of the chattiness of BGP and the processing of what's coming over the TCP sessions, rather than just the TCP sessions alone. So the reduction of TCP sessions here is not really a big significant factor for keeping RRs in place. Next one. Efficient update generation. So in this proposal, as you can see, you can still on IBGP side put every IBGP peer to the same update group or peer group. So essentially, you still generate update once and then replicate it to all the peers, just like you would do on the RR. You can do the same exact code path on the PEs or ASBRs. So with that, there is not much difference. If you're using RTC, for example, then indeed you may actually end up with some post-generation filtering on a per-peer basis. But even that has been solved because we had to solve it for VP and V4 route reflectors. So the same code can be used if you're doing the full mesh from the PEs itself. Next one, please. So now there is, next one. Simple illustration about the idea. So the entire idea is that you will use route reflector as you know it today without much changes with a new Sappy. And that new Sappy will be used to distribute configuration information from the interested parties which want to peer together. And it's done on a per AFI Sappy basis. So you don't have to do blind auto mesh for all Sappys. You can do it pretty much as where needed and as needed. The RR here is pretty much a database. We treat a route reflector here as a database holder. Of course, one can say, oh, but there are so many other databases. And you can say, sure, yes, but RR comes kind of for free here. So we don't really have to worry about deploying some new protocol or some new tool. I see Kaywur has a raised hand. Go ahead, Kaywur, if you have any questions.
Speaking as a co-author, you explained very well the use of RR in auto discovery. However, I just wanted to confirm it that even without an RR, this proposal will hold true.
Well, yes, but the RRs here are used to keep the information about BGP sessions. So I'm not sure. Of course, it can work without it. You can exchange those directly, but you would have to build the full mesh by hand ahead of time.
Yep, that was my point.
Okay.
If the full mesh is already established and you're adding new address families, this should work seamlessly.
Yes, indeed, exactly. Let me finish a couple of more slides and then we go to the questions. Sorry, Linda, I want to just keep going. So next slide, please. Okay, so basically the concept is to define new Sappy, and the Sappy format is group ID with the router ID to make it actually unique within the network. And you can do full mesh or even the scoped meshes creation. So automatically you can do, let's say, full mesh within the confederation if you have convets in your network, and still use normal peering between confederation border routers. So we left that flexibility in place just because there is no cost to it, and allows you to build arbitrary topologies within your network. Especially in the cases where sometimes tomorrow someone may invent a new Sappy, which can be which may require some partitioning or layers. So that's why this kind of group ID is in place. Next one, please. This is just a format of the pure discovery attribute. So basically, within the new Sappy I described, we define the new attribute without, and that attribute will be pretty much available in that new Sappy for propagating configuration information. Now, based on the history of the last couple of interims and meetings in IETF, there may be additional fields required from the work which Jeff was leading for the requirements of auto discovery in the DC, which we may need to add here if we decided to proceed with that work forward. So that floor is open, and perhaps we can discuss what needs to be added, what needs to be maybe removed. Next slide, please. So here's a couple of bits which are left for, which are pretty defined to automate further and provide more flexibility into the provisioning. Next one. And this is the Sappy descriptor. So what I meant by adding additional information, so maybe here in that descriptor, we may need additional information if we all agree they make sense for one use case. So I was kind of meant to show that encoding for additional accommodation. Next one. Here are some more of the details of the operation of this. So, for example, the case of changing router ID on BGP speaker, it will regenerate the BGP and LRIs with the new router ID, right? So pretty much it can be make before break, essentially model, where if you really changing router ID, which is pretty much disruptive event, no matter how you look at that, you can actually still make this discovery graceful. The same for F flag, which is force. For example, if you have already established a session for given Sappy an ID, you can force to recreate it based on the auto discovery information. Another useful thing for this kind of approach is not to establish anything from the perspective of this draft, but only use it to validate if your sessions are established wherever it's needed. So another use case for this draft is in the space of monitoring and operability. Of course, one can argue you should do the management system for doing stuff like that, of course, but this is just kind of a side effect of having that discovery information in one place, discovered information about BGP Sappys in all BGP speakers, and you can use it there, or even you can feed that information to your management system from those databases, because usually it will be at least two different RRs acting as a database, like for redundancy. Next one, please. Yeah, that was the informational model which I described. You can also apply templates to the provisioned in auto discovery mode sessions, and likely that would always be the case, because for some security reasons or for some additional validation reasons, in the eBGP case, you can add some additional security exchange between your peers, for example, but that's all optional, right? So the draft is pretty much extendable. And if the draft is not extended, the point is that you can still provide additional functionality required by local templating. And then during the establishment, that template will be, whether it's a session template or pure template, will be acted on before the session comes up. And discussion, let's move to slide 20. So this one is actually question, is BGP the right model to be contained, or should we go back to IGPs? So currently, from whatever I talked to about this draft with, BGP's closed and contained solution seems to be the optimal one. So I don't think that we should go into the IGPs for this. A main reason why IGPs are kind of harder is that more and more IGPs, now you can see in LSR, multiple hierarchies, not even 2, but up to 6 or 8. So you would have to leak all of those informations around into the all areas. So that's one problem with using IGPs flooding for distributing that information. So I think that's just for up to discussion. I brought it here because I had it in my notes. But currently, you know, we are keep thinking about continuing with BGP-based approach. From each BGP speaker, actually, there is 130 bytes of the size of the message, which is sent to the RR. So it's kind of tiny if you look at the BGP overall vehicle. Next one, please. So basically, another question is, if you already have to provision session to RR, is this really auto? Well, so today I look at the RR for this particular discovery thing, even assuming you are not already peering with RR for other reasons, for other Sappys. It's just like you configure NTP server in your box, or DNS server, or DHCP address, syslog, etc. So basically, I don't see adding another configuration line to your router config to automate something which otherwise takes you know, tens or hundreds of lines. It's a costly offering. So that's about it. Next one, please. I think it will be the last one. Someone suggested actually to also extend it with the adding the peer's name. And I think this is a very good idea because today, you know, we have some extensions in IGPs to allow you to carry the router's name into the LSPs in ISIS, let's say. With BGP, it may be also pretty useful to not only show your peers by IP addresses, but also by names. So easily, this kind of approach can be accommodated with simple extension to the signaling. And last one is pretty much thank you. And Linda, please go ahead with the question, and anyone else if required. Yep.
This question, this reminds me of that other draft we have, like SD-WAN discovery, is along a similar concept, but it's much smaller scope. Like, so do you envision to be kind of SD-WAN edge discovery to be a small portion of this? Because I see there's a bigger, like more of the auto configuration versus SD-WAN discovery is only to discover the edge node, some of the port properties, so that the RR has the database to manage the authentication and distribution of the peers.
So when we wrote this, SD-WAN was still in the infancy, or maybe not even there.
Right.
So this one is aiming pretty much on the one IBGP and now route servers. However, if you find a use case to discover your SD-WAN endpoints, and you find a common or so to say global database acting as the RR, let's say some RR in the cloud, I don't see any problem using this for discovering peers with the SD-WAN as well. And in fact, it doesn't even require, I guess, any extension, because you can actually use the one extension which we added for IXPs, because you will be having a BGP session, I guess. So it may work out of the box if you have a route reflector or some database acting as a route reflector available for sending information to the peers.
Yeah, so in the SD-WAN edge discovery, we proposed a new Sappy to describe that this is actually the information about the edge information. So my question is really, in your vision, like this Sappy, do you just envision one or can be more than one?
So the Sappy I define is just a container to allow exchanging information about my own Sappys, right? So I'm not sure if the Sappy you are referring to is the one which can be fit into this bigger vehicle, or is alternative to the bigger vehicle. But I think it's the former.
Okay. Yeah. Okay. Thank you. We can work out later.
Thank you.
Offline.
Yeah, Kaushik?
Yeah, I have some questions, Robert. This is a good draft. Obviously, you are using route reflector for the IBGP case for auto discovery and route server. But let me start with my first question. So the use case, it's mainly for the IXP. So that's my understanding, that this is the the target audience would be for the IXP use case, and here you are trying to simplify using the BGP, not the using the IGP. The requirement we defined earlier, the in a design team, which was for the data center, and where we have defined the requirements. My question is to the to you and the chairs. Shu, Jep, and Keyur, should we try to also define the similar requirements for the IXP use case, especially for the IBGP and EBGP? And yours is talks a little more on the encoding and the implementation approach, but have the use case and the requirement sets should we define part of this approach, so then it follows then naturally the implementation method.
Okay, I take a stab, and then Jeff can actually speak as well about it. So basically, you are right that this is not targeting the DC environment. So the draft was, the requirements we had about this draft was to have the BGP sessions between endpoints to come up. That's it. What needs to be exchanged with that to make it happen was pretty much as minimal as possible, yet offering some additional flexibility into the provisioning aspect of things. Now, and it's actually, the original work was for IBGP for WAN, and then later we came with the IXP extensions just to allow easier peering between the IXP parties. So I don't have any nothing against writing requirements for WAN if they are going to be substantially different than for DC. But I think what Jeff was originally planning with the requirements was kind of trying to keep it common. So we may actually leverage that work already and maybe spell out that, okay, that requirement, it's only for WAN and that is only for DC. I'm not sure how Jeff and Sue and Kay will want to handle that kind of requirement document, but from my perspective, this work is pretty much aimed at WAN and IXP, and maybe SD1 as Linda added later. Yeah.
You just said, so I made sure I heard it right. Robert, you said it's for IXPs and then data centers. Would you please just repeat what you were targeting this at?
No. So this is for IXP and for WAN, and not for data centers. I never intended this to be used in data center environment. I'm not sure, maybe it would work, but we haven't done any discussions, any thoughts about if it's optimal design for data center.
So that's my question is basically, since it is not meant for data center and it is for the WAN, And I kind of see that Linda's point, and as we kind of discussed, like even for SD-WAN IBGP cases, also it could be possible, like SD-WAN as one of the Sappy to be discovered as part of this kind of auto discovered. But all I'm kind of trying to say that's like we should have a separate kind of requirements doc or use cases like a data center in for the IXP cases, so that it's kind of clear that's what we are kind of trying to achieve, and if this is the only way, or like if there is kind of other approach as well.
Yeah, this is Kevur. I am going to speak as a working group member.
Sure.
I personally haven't seen working at IDR or attending at IDR for every proposal we bring up a requirements document. The second point I would make is whatever we did as a requirement documents, I feel was mostly tailored towards data centers. If you look at a lot of those requirements, it may not hold true, particularly for IBGP sessions. So that being said, I would say maybe, Robert, in the subsequent presentations, we may add the use cases and start with that. Thank you.
So, Kayer and Cossack, Cossack asked me this question before about the data center versus the DTs. As Jeff mentioned in an earlier review of the BGP auto configuration, we started with the data center because people felt that was the most critical at first. Cossack, if you and Robert are really building towards something else, it might behoove you to get your heads together and look at the requirements and see what you think is common or different, and at least write up a short note and send it to the chairs. And if you feel it's an internet draft, to send it out to the draft. It's worthy to discuss. We're probably going to go to these interim formats rather than another design team. So provide us something useful to see so that we can review it. Cossack, I hope that answers your question.
Yes, sure, exactly. So that, thank you. That answered my questions, and I kind of we can work with Robert to kind of as the use cases or the requirements we try to clarify. Means I'm fine either way. It could be part of this or could be kind of separate, but like kind of bring it to the group, and maybe we can discuss like it may not be the extensive requirements like data center, but like yes, this exactly answers my questions. Thank you.
Okay. And if I could finally jump in here. So Robert, this partially echoes comments made by some of the other prior speakers. This is just sort of summarizing some of the things that was apparent as part of the design discussions that we had during the design team work, and how it sort of fits into things now. So the thing that's a slightly awkward fit, as you're sort of getting to, is that you do still need to bootstrap the BGP session itself in order for you to use this discovery mechanism for other BGP sessions. So to some extent, you're sort of recursively going back to some of the problem we're trying to solve in the proposal that some of the other mechanisms might be able to deal with for getting that piece bootstrapped. But that said, the things that are useful is discussion points from this proposal, two big things. Now, the first one is that the actual state that we need for bringing up BGP sessions, including IBGP, that's still the same as what we had been discussing as part of the auto discovery requirements, and the changes necessary to go into this proposal to get the same information present is not that big, so that's not the stalling point. The other thing I think that's actually a useful discussion point about mechanisms like this is effectively providing, you sort of started with the idea of route reflector, but really what you're discussing is a discovery rendezvous point for places that want to do, you can reach my session and you learn it from a centralized database, as you put it. So that aspect is interesting. And if we look at the sort of three use cases that we're looking at for BGP discovery in general. The first one for data center purposes is effectively hop by hop. Having some sort of provisioned mechanism like this, via the management port, is a possibility. Certainly, it sort of fits loosely into some of the ideas that I think Randy is going to be talking about for BGP SPF. If we're looking at something that is like discovering things in IXP, certainly you could run point-to-point discovery mechanisms like we're going to be discussing in the other presentations, but certainly the amount of traffic starts to increase significantly, whereas a mechanism like this reduces the amount of discovery traffic. And if you talk about the third case you seem to be targeting for like eBGP, that's something that either mechanism could be used for. The discussion points for how do you actually tie in your policy for your eBGP become a little bit more interesting. The discovery protocol requirements are leaving things like that out of scope, whereas something like this could actually provide configuration templates as part of the information that's exchanged in the protocol.
Yes, Jeff, I pretty much agree with all what you said. Maybe additional comment, which I didn't say it during the presentation, was that adding the rendezvous point, as you nicely called it, has an additional kind of property of ability to do the policing from central locations on top of what is happening in your network. If you wildly allow any-to-any flooding, you're losing that policy control. Maybe it's good, maybe it's bad, right? There is maybe not one size which fits all, but I just wanted to make an observation like this. And clearly discovering that rendezvous point or discovering, the RR can be optimized. And, for me, it wasn't a big deal to add a configuration line specifying an IP address, maybe even any cast IP address or 2 IP addresses. However, if we need and we want to automate that step, and especially leveraging some other tools which we can have, by all means, why not?
Hi, this is Dave. And speaking as a working group member here, I think this is where we should take a poll from working group to say, hey, do we want a BGP auto discovery to happen within an AS for an iBGP connections? And if so, do we really want the solution to depend on rendezvous point or not, or more? If we want more, like Robert suggested, there were proposals of leaking the auto discovery information into IGPs, and maybe we can resurrect that. If that is not what working group or the operators are looking for, then we can go with the rendezvous point to begin with, or RRs, and then extend it eventually. But that would be a good feedback to get from working group. Thank you.
Okay, in the interest of time, we were already over time for this session.
Can I please ask one more question? So, Robert, my second point was we can discuss offline. I had few more, but as Jeff mentioned, still it needs some bootstrapping, and not only just the kind of definitely it's optimal solutions. You can control the policy as you kind of mentioned, and especially we have seen that SD-WAN use cases. So all I'm saying that's not only just the route needs to know that route reflector, but it kind of needs to have the route reflector also to be configured to exchange that informations, like who are the other clients and etc. So that requires some sort of a minimal configurations even to kind of exchange under this new Sappy to all the kind of a different peers attributes to be discovered, right? And whom we kind of send the distributions that has to be kind of configured in the RR. So that is still there. And I see that the eBGP case is, yes, it is kind of covered, but like a not well extended covered, maybe the route server part. So maybe it would be good, like if we separate it out, like a kind of a, as Kevin was mentioning, I think I like that approach, like a IBGP with kind of within the same AS and having that RR as a central point to kind of exchange the routes with a minimal bootstrapping even in the RR. And then eBGP with the route server, what are the configurations kind of needed and etc. We have to explore. Thank you.
Yes, I mean, one last comment on that, what you just said. Yes, and by all means, one additional data point is that the way we originally thought about this work was the case where you have a lot of Sappys to deal with. If you have only one or two Sappys, maybe this entire discussion is moot. But if you have 20 Sappys and growing, because your network uses more services which are BGP based, then maybe it makes sense to even provision such an discovery around the viewpoint RR and automate subsequent Sappy's establishment.
Sure.
Okay,
I
thank
think
you.
we've gone a long time over. We're going to have to swap over to the other presentations. Jeff was right a few minutes ago. I thought we were coming to a closure. I'm going to bring up Randy's presentation. So we'll go to that next. Again, I apologize. I thought we were coming to a good conclusion. And I have a favor, Robert. Send me the last thing you sent via email, if you would, so I can make sure to get it in the notes. Okay.
Okay.
Let me grab.
Randy here. As the previous presentation, this one was not designed with a direct target for IDR. It's from the link state working group. And the next slide, please. It's 3 drafts because that was the structure over there. And the primary goal here was discovering layer 3 topology and keeping it alive for BGP SPF, but at least it's in the data center. Okay, so BGP SPF is designed for data centers. So this was designed for a peer discovery, but also not just BGP, but in general dealing with a multi-tenancy data center topology. So you will see some things which are designed for a much larger scale data exchange than maybe is necessary for the IDR application. Slide, please. So you want to find your neighbors. You want to learn their layer 3 point-to-point addresses. And then you want to configure BGP SPF. Slide, please. And the main base draft is the LSVR L3DL draft. Slide, please. Poor Sue is learning why I wanted to run my own slides. So what's happening is you have devices running BGP SPF, and they're trying to do BGP over TCP, but they need to find each other. So down at layer 2, we exchange Ethernet PDUs and discover the point-to-point links and exchange those PTUs to describe the layer 3 addresses. And then we can do link checking, and we can exchange AFI-SAFIs. Next slide, please. This is not a routing protocol. It's just discovering the layer 3 addresses on point-to-point links. Now, I'm lying. It's slightly more than that because maybe you want to see behind them to loopbacks. But that's about it. Now, next slide, please. We get into it's designed to carry a lot more data. They're Ethernet frames, the PDU that's up top. Are Ethernet frames. They are gathered to form an L3DL PDU. The L3DL PDU has the PDU type, payload length, normal things. It has a signature so that The data can be checked for authenticity and integrity. Next slide, please. It's layer 2 transport, and it can hold a ridiculous amount of data. As I said, it's probably not necessary for the IDR application. For the data center that BGP SPF lives in, where you could have multi-tenancy, you could have one server that has, 500 tenants each with their own IP address. So this is meant to scale for that. Next slide, please. Okay, so they're big PDUs. For your information, Jorg was very kind, did a transport director early review of this. We had a couple cycles, and that was very helpful. So that stuff that I just showed you, even though it's probably a little gunky for our application here, does probably hold up technically. Next slide, please. Why didn't we do it at layer 3? When this runs, there is no layer 3. The object is to learn the layer 3. So it's a cheap TCP-like protocol with reordering, retransmission, acknowledgement along those sessions, etc. So, but it's pretty lean. Next slide, please. Okay, it's fully stateful, has a session per peer. It has grateful restart, and state may be resumed. Okay, so you can see the influence of BGP. No, you can change. It's fine. The influence of BGP heavily. Okay, there's an open, which has a nonce. There's something we call the link level endpoint identifier, which may be the MAC. It may be something else. They're in different environments, they're different things. You may be interested in the attributes, and I'll do a little bit more about them later, but there's essentially a list of attributes, and they can be arbitrary things. If you want to describe your role in the CLO or describe what you can do, there it goes. We did not have the hubris to think we knew the specific set of attributes that would be mandatory to implement. And then we get into the keying stuff for the authentication, and PDUs have serial numbers. Next, please. That's the open. We now exchange encapsulations. So here would be a count, and then a list of encapsulations that I'm handing my peer. And again, the serial number for that whole restart nonsense. Next slide, please. So in for instance, this is an IPv4 encapsulation attribute, and it has flags that say, for instance, I just want to draw your attention to this. Oh, this is what I'm giving you is a loopback address, because BGP peering is often via loopbacks. So we needed to denote that. Slide, please. Okay. So there, it is meant to support BGPF in a closed style data center. So Sue brought up the problem of multicast storms. We don't think they're very likely to happen in that environment. Okay, there's much more detail in the draft that you can go to, but I don't want to bore you to death with packet porn. It's just a way for peers to discover each other's addresses. Next slide, please. Now oh, yes, by the way, we do have 2 implementations. One in Python 3, which is actually an older version of the protocol and much simpler. It wasn't designed for 1 million encapsulations. It could probably only handle a couple hundred. And you might take a look at that old draft to scale this back to more suit what I think IDR needs. And we also have one in Golang. So next slide, please. So we wanted to have some security. Instead of painting it on afterwards, it's kind of designed in. Next slide, please. So the open PDU, as I showed before, exchanges a key. And we have the type of it and its length and the key itself. And then the open is signed with that. Next slide, please. There are two main flavors. Okay, the key in the open PDU is the public key of an asymmetric key pair. The sender signs with the private. The device sending the open can use the same key or different key for different links or different flavored links, etc. Makes no difference. Next slide, please. There are two general approaches. Trust on first use, like you do when you SSH and it says, hey, this is the key of the server. Do you want to trust it? If you're foolish, you say yes. If you're not foolish, you go to some external authority and you say, does that key fingerprint match what's in the external authority? And that's what we mean here, the latter, as PKI based. Okay, but next slide, please. So trust on first use, the sender generates, it's believed without question, which is what we meant by trust by first use. I once abusingly called that marriage on first date, but it's far too common to ignore. And all subsequent PDUs can therefore be authenticated to come from the same attacker. If that gives you comfort, so be it. Next slide, please. PKI based is you first have to declare what your public key is and put it in the central database. Okay, and the central database signs it, and therefore the receiver knows the central database's public key and can validate your public key. Next. Don't worry. This is next slide. This is not X509. X509 is way too complicated. These are just a central authority signing over all the players' public keys. So, but every device must know the public key of the central authority. So when it receives your key on the open, it can look at that and it has been signed by the central authority. So therefore you trust that it is not trust on first use. Slide, please. Verification is the same in either case. The receiver can't tell. It's just whether you trust that it opened. Okay, do you go to the trust anchor or do you make the leap of faith? Next slide, please. The choice of which is left to the operator constructing the data center. It's just a matter of philosophy. Okay, so next slide, please. We're finally going to get to BGP. But the protocol being described here is called the upper layer protocol because it's not necessarily specific to BGP, but BGP is the only upper layer protocol we've developed so far. Slide, please. Okay. It's meant to allow configuration of arbitrary protocols. BGP is the only thing you need in SPF. Next slide, please. There's an L3DL PDU that says what type of upper layer protocol, which in our case is BGP, the count of attributes, and an attribute list. So again, another way of saying, hey, I'm a leaf, I'm a spine, I like chocolate ice cream, etc. Next slide, please. It's, again, provide the minimal set for the open to succeed, next slide, not to replace or get in conflict with the data exchanged by BGP open. Next slide. And the reason is, as is in the draft, the requirements draft, is multiple sources of truth or a sure bet for pain. Next slide, please. So what attributes do we need to exchange? We need to exchange the AS number. We need to say which address I want to use for peering. Next slide, please. We need to exchange the authentication data for BGP. I don't mean the PDU signatures. I mean the TCP MD5, AO, et cetera, is there are the BGP TCP going to be authenticated? Is that saying I've run my half an hour? I don't think so. Sue, am I okay? I'm nearing the end anyway. Yes, there's a PDU for...
You're fine. My bad. Go on.
No, I'm almost at the end. Yes, there's a PDU for IPv6. Sorry, I always get in trouble for this. Again, let's go a little further into the attributes. Slide, please. Okay, so again, there's an attribute count, a list of the attributes. An attribute has the length and the value. Big surprise. I realize these PDUs are pretty boring. This is a feature, not a bug. Next slide, please. The base protocol allowed marked loopbacks, so we handle loopbacks. Next slide, please. And that's pretty much the whole show. Next slide, please. Of course, I lied. We'd like to hack it to better fit IDR. I think if you got serious about doing this at layer 2, as I said, I don't think you need the full being able to carry, 2 to the 50 packets. So I don't think the hundreds of addresses and encapsulations are needed. And next slide, please. Now I am really at the end. So, Jeff.
Randy, thank you. So a couple of comments. The things that aren't quite completely in line with the auto config design team considerations, thankfully those are just attributes, so I don't think that's a big deal. The question I do have, though, which you probably have experience from LSVR, is how does this interact with the state machine, when TCP is capable of coming up? Because obviously you're exchanging information about layer 3 endpoints before layer 3 itself may actually come up. So we have to wait for IP addresses to get configured, duplicate address detection to finish, ARP to actually do its thing, and then BGP can finally do its job. How does this typically behave, once you actually use this mechanism for like LSVR?
Randy, I can take it.
Go for it, Kayer. I don't think this is... and you're diving down an unnecessary rat hole. Go for it, Kayer.
Yep. Speaking as a co-author, not as a working group chair. So this would happen even before the state machine goes in. You would establish
Exactly.
the layer 3 session or at least my bad. You would establish L3DL session first as the link comes up. As part of L3DL session establishment, you would exchange what BGP parameters you want to exchange on a single hop link, which is for the data centers. And once that happens, you would then feed it into a database that is very analogous to a config database inside BGP that says, here are the neighbor based parameters and neighbor relationship and neighbor AS number that you need to start establishing a session with. And that is when the BGP state machine will kick in. Yeah, hope that clarifies. And while I have a mic, I wanted to say that Randy did talk about this, but we've got 3 implementations of 3 different flavors and 3 different code bases or languages where this extension and protocol is written into. So we've got a multiple implementations of this, and some of that will get open source pretty soon. Thanks.
And this is based on some old presentations, and it doesn't go into something that is actually in the protocol, which is what happens when the BGP parameters changes, what happens when there's an established session, etc. And those information are actually exchanged, and there are rules for how they're digested.
Right. And
That's
the
in
motivation
the
for the
third
question,
draft.
Randy, is, basically if BGP is, attempting to hit TCP hard and can't, run up, if you're using the default stuff from 4271, you start hitting internal session backoff timers. And part of the motivation for asking each of the proposals, how do you intersect with things, is along the lines of, if you, as an example, have a discovery protocol that's running at the IP layer, that IP is probably working, and there's a good chance that if something's sending a discovery packet, it's ready to accept an incoming BGP session. Whereas if it's not, you may end up hitting some of the back off timers, and as a side effect, that means when you plug your wire in, how fast does BGP itself come up so that your fabric can actually be online?
Yeah, so that's a very good question. And I think the part of that answer, as you know very well, will reside into implementation details, and part of the answer would be as part of standards body work. Now, if you recall, Sue had a draft in this about I want to say about somewhere around 2005, 2006, where she had suggested how do you do exponential peer backoff, depending on how and when the state machine goes down. In L3DL, we have solved that very much at an L3DL level to say, hey, when does the information get pulled back versus when does the information get re-announced? As long as that doesn't flap, that is treated like a config change, very much saying, hey, how many times did you unconfigure a neighbor or configure a neighbor? And after that, as the session flaps, you would have an exponential backoff timer that would hit in, and then that would go ahead and do the necessary backoffs from the session re-establishment point of view. Yeah.
I think we're getting overly complex here. BGP can, in case of failure, can go look and say, are there other addresses? Do I want to back off, etc. This protocol merely provides you the list of people willing to talk BGP to you and what flavors they want to talk. Your choice at the BGP level. So you can fail with one of your peers' addresses and go for a different one. But that's not what we're trying to solve here. We're just trying to find you the list of peers. Discovery was the key word, I think, for this meeting.
So I agree with your assessment there. This, as presented, handles discovery perfectly fine. One of the discussion points that's been raised is how quickly do things establish once you have discovered a peer. I will take your answer as not currently discussed in this proposal. Thank you.
I'm
one quick comment.
gonna. Okay, Care, I'm gonna. I'll go then after you. I've
Yeah.
one discussion point because I wrote with Jeff's help and other people's help the FISM for 70 for BGP right now. Go ahead.
Yes, thanks. Speaking as a working group member and a working group chair, Jeff, I think that's the last point that you made does deserve a set of text, at least in the solutions where it says, hey, how do you handle that, and what is an impact with FSM? Even when there are no changes that are needed, I think a description would be helpful at the minimum.
Right, and the motivation for the question, having dealt with misconnectivity issues and existing BGP implementations. This is to Randy's point. BGP already knows what to do for these things. Unfortunately, part of what BGP actually does in the field for these things is the existence of some sort of connectivity issue where it's configured, it thinks it's there, it tries to connect and fails. The back off timers can get in the way of fast peer bring up, and for something that might be like a exchange point router, might be eBGP peer to an ASPR for internet purposes, those timers may be okay. But if you're trying to actually get things working for a fabric, your bring up and failure times might be more important as you have technicians basically moving cables around your racks. So that's the motivation to have these things discussed.
So
I
Jeff,
certainly don't want to contribute more words to this discussion.
Okay, Randy, did you have Jeff? Did you have any other? Excuse me, Randy. Did you have any other points you wanted to make? Not on that particular point, but on anything else. And is that in the chat saying no?
This is impolite to the next speaker.
Yes. Okay. I will stop here. Let me go on to the next one. We'll start with that. By the way, folks, given we've allowed these discussions, the first discussion to go long, we will probably go 10 minutes long. That's probably the chair's problem. And I'll take that, as I should have pulled the ripcord on Robert sooner. Go ahead, Shiva. With this, you will have a full 20 minutes to 11:40. Ajun, you will start about 11:45, and we may go as long as 12:15. This session will stay open to 12:30. Thank you.
Thanks. So, are you guys able to hear me? Like, I just wanted to confirm before starting. Hello.
I could hear you.
Thank you.
Yeah. Okay. Yeah. Next slide. So this is a proposal that we want that came out after the AutoConf consultations draft has been brought out by the IETF-IDR team, and the scope of this particular auto discovery protocol is limited to the cloud data center networks. And the first thing that we wanted to achieve through this auto discovery protocol is to reduce the amount of configuration on the in the devices used in data center, and this is primarily scoped for the layer 3 single hop connections. And in line with the AutoConf considerations draft, we are trying to the protocol is trying to propagate the minimal transport information required for the BGP to bring the initial TCP connection up. Next slide, please. Yes. The service advertisement protocol, it is based on a UDP multicast protocol, and it will have support for both the IPv4 and IPv6 service discovery. The messages are based on TLV format, and the protocol, how the internal working is that there is a initial advertisement with all the required service BGP endpoint information, advertised with an uh, its validity, its lifetime validity, and it is required for the service advertisement protocol to basically refresh all its state uh, before its timer expires, the validity time expires. Uh, we wanted to keep this protocol as loosely coupled with BGP as possible in order to avoid constant interaction with uh, BGP protocol running on the devices. Next slide, please. Yeah, so the protocol packets, the messages that we are going to be using are of two types. One is the service advertisement based message, and the other one is the BGP advertisement message. So these both messages would be included in a protocol PDU, which consists of header containing the version, length of the message, and identifier. This particular identifier makes sure that we know which router we are communicating with, which router the local device is communicating with, and ensures that all the ensures that basically we can always determine the device that this particular PD was sent from. Yes, next slide, please. Yes, the service advertisement base message is a base message for this particular protocol, which consists of the mandatory parameters that are required to send along with all the other messages that we send in this particular protocol. This contains TLVs, primarily contains the TLVs that are the lifetime of this particular information, and it is definitely driven by the sender, because it lets the receiver know that this particular information is valid only for a given amount of lifetime. And the other one is the config sequence number. This helps the receiver know if any state uh, any state with respect to this particular transport endpoints has changed by the time this particular message has been sent. And the other one, to provide security for these particular packets, we had included the authentication TLV as well. And this particular authentication TLV consists of the uh, verification information that is required to basically send the packets. I mean the hash values calculated with a configured authentication mechanism on both on the sender and the receiver. Next slide, please. Yes. Now, the PDU that is concerned with the BGP Auto Discovery mechanism, it again, as mentioned earlier, it would only propagate all the minimal transport information that is required for the TCP connections to be established, and BGP can take it from there to uh, negotiate all the parameters that are done as currently in through the BGP open messages. The TLVs that are propagated in this particular service advertisement messages are the local address. This is primarily the peering endpoint, the transport endpoint the sender wants to establish a connection with. And the other one is the TTL value. This is a TCP parameter. And then the security authentication. This is not the hash value that we use in the service advertisement base message, but more about the authentication options that the sender and receiver's BGP sessions should be using to establish the BGP connection. This could be either the TCP/AO or MD5, or could well be the keychain mechanism as well. So that and we need to include a unique ID that is already synchronized along on both the devices, and this could be used by the BGP protocol to bring up the BGP TCP sessions and ensure that the security of the security of the connection is still existing. And now the link address. So this link address is primarily for a case where we might want to establish a connection with the loopback address, but since the connectivity is not existing to the loopback address, we would be sending a link address on that particular link we could use to the receiver could use to reach the sender. And this can be either of the v4 or v6, and the link local address could be a v4 and v6 as well. And the last one is the transport preference. This again is just a recommendation from the sender to the receiver about which particular address family that the receiver should prioritize in establishing a BGP connection. So this basically denotes whether this receiver should prioritize v4 or v6 peering addresses transport endpoint to bring up the BGP connection. And yeah, next slide, please. One important consideration that we wanted to go through was what should BGP do on the expiration of the transport information received over this protocol. It is important to consider that this particular protocol exists to bring up the BGP connection initially, and as we want to keep it as loosely coupled with the BGP in regards to the flapping or the termination of BGP session. So two possible approaches that we are proposing is there could be an operator configured interval for the auto discovery protocol, where once the transport information expires, and the state is, if it is not refreshed after this particular operator configured interval, we should bring the BGP session down. And the other end is the other possible recommendation is the sender itself, which is not willing to keep the connection up with this particular neighbor, could terminate the BGP connection. And for this particular approach, we think that right now all the notification mechanisms that we use are usually uh, make the remote end to retry the BGP connection again. So for this case, we would like to propose another subcode for the C's notification code that would let the receiver know that this particular connection should not be brought up, should not be retried again, and let the auto discovery protocol take care of what the new transport information that the receiver should use to bring the BGP connection back up. Next slide, please. Change in, oh, sorry for the typo. Say suppose there is a change in transport information. The receiver would know that this is from the same device as earlier, from the identifier that is put in the header of the service advertisement protocol. And with the peering address, the local address TLV, which lets us know that this is the peering address, peering endpoint, we could determine the BGP on the receiver end could determine that there is a change in transport information that needs the receiver to flap the BGP connection and bring up the TCP connection again with the new TCP parameters as propagated by the sender. These parameters could be authentication, which when changed would require the BGP to bring up the connection again with the new parameters required. And yeah, the config sequence number is the one particular number, the TLV in the base message that is used for that should be used for a to let the receiver know that there is a change in the transport information that the BGP will be using to bring the connection on. Thank you. Yeah.
So, Shiva,
Yeah.
let's go through a couple simple questions. And Cossack, I see your hand in the queue. So tell me what's the information, what's your target? Are you targeting the data center?
Oh, sorry. So yeah, we are targeting the data center environment, and the state is would be basically cached by the service advertisement protocol on both the receiver and the sender.
Okay. And since you're targeting the data center, can you compare and contrast, since you've seen Randy's presentation, the difference between your presentation and the state, not the that you're carrying, and the state that the L3 that the previous presentation is given to you?
Sure, sir.
What's
So
different?
yeah, so the one important thing is the propagating of the AFI-SAFI along with the peering address to let the remote endpoint know which particular AFI and SAFI routes will be exchanged over the session, and the other one was the BGP related parameters that were propagated, such as the AS number in that particular message. Yeah.
So though those could be attributes that get passed in the other protocol. Is that what I understand from you, just your last comment?
Yes, that's right.
Yes, they could be. Okay.
Yeah.
So we essentially have state, as Jeff is like to say, the state passed is the same. Now we're talking about the mechanisms.
Mhm.
Is that correct? Okay. Then I will
Sure,
let
sir.
Kair, did
Hey,
you have a chair's comment, or are you doing
yes.
a working group comment?
Working group co-author comment.
Oh, if it's a co-author, are you co-author on this draft, or on which draft are you referring to, Kair? I didn't think you were on
L3DL,
this. Okay, please go
L3DL,
ahead with the.
and I just wanted to quickly say that the office are also carried in L3DL.
That was my understanding as well. So as far as I can see, these two proposals are carrying the same state information. Do I understand that correctly, Kair or Randy?
That is correct.
Okay, so now we're
I
talking about mechanisms for passing. I just want to make that we've got Robert's proposal is over here outside of the data center. These two proposals are the same. The state they're carrying is the same. What we're now looking at is, what do we think about the mechanism for carrying? Cossack, did you have a specific question for the author?
Yes, sure. I have one specific question just for this.
Mm-hmm.
Can I go ahead? Okay. Yeah.
Yes, and just Cossack, give me a minute. Ventant, did you have some response on the on that I needed to follow up to Kair on the state information?
No, sir. Yeah.
Okay, thank you. Then Cossack, please go ahead with your question.
Okay, this should be quick. So, hi Venkat. So I'm just trying to understand the two parts. So initially, SI advertisement and then BGP advertisement, and you mentioned that it is used as UDP multicast based protocol for sending the advertisement. Like my question is how do we kind of initial bootstrap or configure? Like how do we know that who are the kind of multicast peers and who sent this message? Kind of who is the sender and who is the receiver? How do we handle that?
The sender is basically denoted by the ID information that we pass along the service advertisement packets, and the based on the interface on which we receive this particular messages, we could the receiver could determine basically the sender being the sender that is sending the information. Basically, yeah. Sorry.
So don't we need to configure who are the receiver for kind of initial configurations that needed where that the UDP multicast will go?
Uh, So in the data center environment that we are targeting, it would be connecting to the peering endpoints on all the interfaces. Uh,
Okay.
it has, yeah.
Are you
That
sending
is my
to a
understanding. Yeah,
Are you
yeah.
sending to a multicast group?
Yes. So, yeah.
Okay, so you're assuming that the layer 3 multicast group will reach all of these other players, and that the data centers have enabled that group to be sent. That's your
Uh,
assumption.
that's right. So, yeah.
Okay, thank you. I'm just trying to be
Yeah.
clear.
I think that's clear.
I'll,
Like,
I'll,
yeah. Yeah.
sorry, I like to add it on, right? So when this protocol comes up, it will register with that particular multicast group, right? And
Mhm.
that will enable the devices, right, that will receive these packets, right? So the kind of configuration we are envisioning is, right, it's a per interface configuration. So you can kind of template configuration that can apply on the pre devices, right, in a predefined manner, so that all these interfaces, the protocol will start sending the multicast packet. Will that clarify your question?
Yeah, sure,
Um,
clarifies. But also, kind of, I see that there might be a lot of multicast message exchange would be going on, right? Because each peer might be in a data center having a peer-to-peer connection, and it depends on who is the sender. A lot of.
This is a link. Sorry, this is a link level information, right? And it's also have a predefined configuration that user can tune it on, and it's also the implementation wise there will be a smartness built in the implementation that will put it on the spec itself, right? So that
Okay,
will kind of smart enough to figure out when to send aggressive, when to send it's lower down. The steady state typically send it as a lower down the timer. In the initial bootstrap side, it will be probably little aggressive.
okay, thank
so
you.
for this case of being a bit smarter, as you noticed when I sent a note to Randy about multicast storms, I'm going to ask you, have you implemented this? What sort of load does the L3 multicast do? How do you know that you're not, blasting everything?
It's the smart understands. I mean to say that it will probably not order of seconds, right? It is on the scope of the interface, right? The assumption I have is right. With the per interface level in the order of seconds, it will not be the multicast blast.
I think my question was unclear. Cossack, I think you're done with the queue. Is that understand that you've finished? I'm going to let that go to Randy. Um, Go ahead, Randy, ask a question.
So at a high level, this and L3DL are quite similar. You can screw with the packet formats, etc., etc. This is doing L3 UDP multicast for discovery as opposed to a layer 2. in layer 2, we do have the ability to decide from the sender point of view, the flavors of MAC used to either pierce switches, intermediate switches, etc. We don't see them too much in the data center, but it's we got pushed and specifically went into that because the LLDP people are very concerned about that area, and it seems reasonable. So you have to be able to transit media converters, switches, etc., even in the data center. We can, in either of this or L3DL, you can start tuning backoffs and packing and all those things. The question is whether you want to trust L3 multicast UDP or L2, and that's just, I think, will eventually come down to a preference.
And I will go with Randy that that's at a high level. I think that's what I would guess as well. My question to you, Shiva, and Minto, is have you implemented this? Have you looked at this problem? Because now we're down to same information as Randy clearly put it, L2 or L3 transmission. Tell me, how have you implemented it? What problems have you seen?
So one thing before I get into the implementation, right?
Oh, sure.
So we have seen other protocols, right? OSPF and that LDP and other protocol using the similar mechanism, right? It's there, the multicast packet, right? We are kind of using the similar lesson learned from there. One. The second one is regarding the implementation wise. We have we don't yet fully implemented it, but the base protocol we tried it on. So we are going to implement it on. So
Okay.
we have a smaller prototype that's initial bring up of this simple session. That's what we had.
Okay, I'd be interested in that. Second, OSPF and ISIS use specific group addresses which have been carved out by many people. So I was trying to dig in to see, but yours could be another one. Any other questions, folks, before we go to the next presentation? Any final comments, Shiva or Minto? Okay, well, we're going to be only a few minutes late then. We're gonna switch away from the auto configuration topic. Thank you very much for Randy for catching us up on time, and for Shiva, and the chairs will try to do better about keeping people to time next. We will be a few minutes over. June, let me pull up your slides.
Hello?
I can hear you just fine. Go ahead, and I'll run slides for you.
So here we want to give some update and discuss on the VPN prefix ORF solution. So this draft just replaces the previous RDOF draft. Yeah. Motivation of this presentation, I just said describe the update on the previous RDOF draft solution. And we want to reach consensus on the proposed solutions and for the updated solution draft. Okay, next. Yeah, we have presented the detailed scenario and solution in previous interim meeting, and I think the IDR experts have consensus on the problems. For the solution, we have discussed on the main list, and also we have discussed with Kier and Susan and offline discussion. So based on the comment from this discussion, we have made the update. Okay, next. Sorry, the main content for the updation is we under the optional TLV field within the previous RDOF encoding. Currently, two optional TLV are defined in the document. The first is the source PE TLV. This TLV is used to indicate the source PE of the excessive VPN prefix. The second is the root target TLV. It is used to indicate the root target associated with the excessive VPN prefix. Next slide. Yeah, here I just give the example for the application of the source PE TLV. From this graph, we can see that if we in the intro as unique RD scenario, that is all the RD in different PE is same for VPN1. So if the P3 send out the excessive VPN route, and it will overflow the VRF on P2. Based on the previous version, if the P2 send only the RD ORF message, it include only the RD information, for example, RD1, then all the VPN prefix from P1 and P3 will be filtered on RR. So the communication between the P2 and the P1 and between P2 and P3 will all be broken. So to fix this issue, we think it is necessary to end the source information of the overflowed PE, source PE information. So if the P2 send the VPN prefix ORF with RD1 and P3 info, so the RR will filter the VPN prefix only from the P3. So the communication between P1 and P2 will be continued. So we think this is a reasonable solution. Okay, next slide. So this is the application of the root target TLV. So we also discussed the scenario for intro as multi-RT scenarios. So that is to say, if the excessive VPN prefix associated with several RTs, for example, RT1, RT2 from the P3, and such excessive VPN route overflow only the VPN1 on P1. And so in previous solution, the P1 cannot send out the RDRF message because the VPN2 also want to such prefix. And P1 can only send out the RDRF message only when all of the VPN is overflowed. So we just updated the solution. So when P1 detect only one of its VPN is overflowed, it can send out the VPN prefix with the RD set RD3 and also associated overflowed the RT root target of the overflow VPN, for example, the RT1. So in this situation, the RR can filter such accessible VPN route on behalf of the PE1. Okay, next slide. So the summary of the update is we think the additional information can give more flexibility for the device, for example, the PE and R, to finally control the accessible VPN route. And the communication disruption among PEs are reasonably controlled. And our additional information can also be added later if necessary. Next slide. Yeah, we think such updates can address the comment from Robert. Robert has mentioned earlier that we should add the RT information for the filter action. So we analyze the scenario that is want to use the RD and want to use the short PE and want to use the RT information. So adding this information unnecessary, on demand, can give the final control of the accessible VPN prefix. Okay, so that's all. We think it is the right time to adopt the update draft if there is no more comment. Okay, thank you.
Agent.
Yeah.
Any comments? I'll take one more question. I realize we've had a long interim. Any more comments or thoughts on this proposal? Okay, we'll give you a little bit of time to comment, and then we'll try an adoption call and see if everything looks fine, probably the beginning later this week, so the authors can get some feedback prior to the IETF draft closure. Anything else for this discussion? I want to thank Asian for being very quick on his presentation, and for Randy and Shiva for being very snappy with their presentations today. Okay, if that's it, Jeff, any final comments, or Kayer?
I'm good. Thank you so much.
I think my only other comment is Alvaro sort of reminded us we do actually have an LODP proposal that's out as well, and that does have some deployment. But that said, you know, not completely speaking for AC, but I'm participating on the draft. The conversation that's been trying to get moved forward across all of the proposals has been, let's make sure the important pieces of the core state's all present, and we're all steadily converging that direction. And as was noted earlier in the discussion, we'll probably end up having a lot of our preferences for this chosen based on, you know, what transport mechanism we want. And it's even possible that you know, the right answer might be to carry the same state in more than one mechanism, depending on what your deployment considerations are. Beyond that, I have no other comments.
The conclusion. We'd like to hear more about that. We may offer AC a one more virtual interim on this to get his protocol. I scheduled these interims on his vacation time, so we'll see what we can do. But I think, like Jeff, we are converging on the same state is being carried in the protocols, preference between L2 and L3, and we'll talk about ACs probably at another interim. Thank you all, and we see you at IETF 112.